So everybody should have out in front of them a unit circle with coordinates because you're going to need it. This unit as well relies on your memorization of that unit circle, or at least you know how to create it from that first quadrant. I mean, that's what you really need to have, and you can build from there. Let's get started. So the first thing that we're going to do is remember how we restricted the domain when we found unit circle values. And there's a specific way that we restricted sine, cosine, and tangent. And this is like what would happen if you were to type these into the calculator. The calculator only gives you, it restricts it down. If you're finding sine, cosine, or tangent, it's going to restrict it down to 2 quadrants for each one of those functions. They're not the same for every function, so we're going to have to go through them. It restricts it to 2 quadrants, 1 positive and 1 negative quadrant for each one of the functions. So when we talk about sine, sine is restricted to, I'm going to kind of draw this onto the side. So sine is restricted to, if you had the unit circle, sine is restricted to the side. So from negative, this would be negative pi over 2 to pi over 2. So we restrict the sine, we restrict sine to those 2 quadrants when we're looking for angles. So if I were to sketch out that graph, so I'm restricting it to negative pi over 2 to pi over 2. And we remember that the sine wave, it goes like that. But that starts at, I have this down far enough. This starts at 0. So we're going to back it up to where that it goes back to negative pi over 2. So I'm going to sketch this graph. Instead of going from 0 to 360 or 0 to 2 pi, I'm going to go from negative pi over 2 to positive pi over 2. And I remember that that graph starts at the middle and it goes up. So I'm just going to continue it backwards. So it's going to go down. And we remember that we're bound by that sine goes all the way up to 1 and down to negative 1. So I've restricted the sine graph to begin and end here, and I have a definite beginning and end for my sine wave. So my domain isn't all real numbers. I'm starting and stopping that domain. I'm restricting the domain, and I'm restricting it to the side. The domain will be from negative pi over 2 to positive pi over 2. And because your graph actually lives there, you're going to make sure you use brackets and not parentheses. So my domain from negative pi over 2 to positive pi over 2. My range, my graph can go down to negative 1 and up to positive 1. The whole reason we restrict the domain is because when we make the inverse, we want it to also be a function. So remember that a function has to pass the vertical line test. Yeah, y'all remember that? A function has to pass the vertical line test. If I took this curve and I put it on its side, so if I take this curve, because the inverse just switches x and y. So if I took this curve the way it is without restricting it and I put it on its side, I would get something like that, right? Yes, no, maybe so. Would this be a function? No. And that's why we have to restrict the domain. So we cut off pieces of it so that we only get this one piece that if we turn it on its side, you will get a function. So that's the whole reason we restrict the domain. That's really important language. We will restrict the domain. And that's the whole reason we do it, because we want our inverse to be a function. So when you restrict the domain, when you create an inverse, X and Y switch. So when I go to make my inverse graph, instead of my x-axis being negative pi over 2 to pi over 2, that's going to turn into my y-axis. So negative pi over 2 to positive pi over 2. And then my y-axis is going to turn into my x-axis. So I'm from negative 1 to 1. Make sure you put the negative 1 on the left. It's kind of helpful if you come over here and you identify a couple points. Really, if you have 3 points, you can create the graph kind of easily. So I'm going to come all the way over here. I've got a point at negative pi over 2 comma 1. So negative pi over 2 negative 1. So that's a point. I also have a point right here at 0, 0. I also have a point at the end at pi over 2, 1. So I have 3 points, and I'm going to transfer them over here to make 3 points. So I've got my 0, 0 point. And remember that when you make your inverse, you switch X and Y. That's what we did on the axes, so that we have to make sure we do that with our points. So now I'm going to go to negative 1, negative pi over 2. So negative 1, negative pi over 2. And then positive 1 pi over 2. What's interesting about these 3 points and these 3 points? Do what? They look like they're in the exact same spot, right? Okay, what we have to be careful of is that we don't make the same exact graph. So inverses reflect over the line y is equal to x. So the way they curve is going to be slightly different. So if I was going to reflect over a line that was right here, then this curves up. My inverse is going to curve down right there. So my inverse will kind of curve down. And then here where I curve down, I'm going to curve up. So this is my sine, my inverse sine. One thing that I want to point out, why do we do inverse? What's it important? What we have to get in our brains, what we have to make stick is that anytime you see inverse, and I always call it inverse sine. Arc sine is the same thing. I think it's just terminology. They mean the same thing. I think older books, and I've noticed just in the math world and talking to older generations, they tend to call it arc sine. I call it inverse sine. It's the same thing. So the words can be used interchangeably. And this is the symbol for it. You've got the little negative 1. It's not raised to the negative 1 power. It is inverse. Inverse, we need the word we need to think of when we think of inverses is that inverse has outputs that are angles. Okay, so inverse has outputs that are angles. So if I have this as my domain and this is my range and I switched X and Y, my domain and my range are also going to switch. So my output now, and this is what we were just writing down, my output now is angles. So I have negative pi over 2 to positive pi over 2. And my domain flips to negative 1 to 1. And again, I want to highlight that the output is angles. And you'll see this all over my slides today because I cannot stress this enough. We use inverse to find angles. The output is angles. Maybe it's output are angles. Are we good with the graph of inverse sine? We're going to do the same thing to find the graph of inverse cosine. So again, like we had to restrict the domain for this to the side of the graph. We're going to talk about how we restrict the domain of cosine. And I know that we've learned this before because we've done inverse before where we've had to go find values and we looked in specific quadrants. So it should feel a little tingly in your brain. So when we do cosine, we're also going to restrict the graph, but we restrict it to the top or the cap. And the cap runs from 0 to pi. So we're restricting the domain. So in a minute, when we use those unit circles that we had to dig out, when we look for cosine, we're going to look for cosine angles in the first or the second quadrant. Again, we pick a positive and a negative quadrant for cosine. And then for sine, we had a negative and a positive sign as well. So if I graph my cosine, so this one I'm restricting it from 0 to pi. So I have 0 and then I have pi. Of course, in the middle, I will have pi over 2. So I'm just actually drawing the first half of my cosine wave. So the first half of my cosine wave, again, cosine and sine are both restricted from -1 to 1. When I create my wave, cosine always starts at the top, and positive cosine graphs make a smiley face. So there is the first half of my graph, and it would continue up to make one full rotation, but we're not doing one full rotation. We're restricting the domain to 0 and pi. Again, we're restricting it because if we take our cosine wave that looks like this, and we turn it on its side, we were to turn it on its side, you would get a wave that looks like this. Let me move it so you can see it. And it would keep going like this. And does this pass the vertical line test if it kept going like this? No. So that's why we restrict the domain so that we don't have this. Oops. So we will have a function. That's not a function. So we want an inverse function. So I can identify my domain and my range here. So my domain goes from 0 to pi. 0 to pi, I restricted it and it lives there. I actually have points at 0 and pi. The graph lives there. And my graph is bound between 1 and -1. Make sure you put the -1 first. Before I even graph it, I know my domain and range because I'm just flipping these. So my range is 0 to pi. Again, I'm going to identify that my output is angles again. When I create my inverse, my graph of my inverse function, again, I'm going to have X and I'm going to have Y, but I'm switching them. So now my X-axis, it's going to go from, sorry, my Y-axis is going to go from 0 to pi. So I'm not going to have any graph down here. kind of like I don't have anything negative over here, so I don't have anything negative. I'm going to start from 0, and then I'm going to have pi over 2, and then I'm going to have pi. And then I'm still running from -1 to 1. Remember, -1 needs to go on the left. I'm going to find 3 points as well because that's going to help me make my curve. So I've got 1 point at 0, 1. I have a point right in the middle at pi over 2, 0. And then I have a point down here at pi -1. So when I take these points and I put them over here, I have to switch X and Y again to make my curve. So my first point, and it doesn't matter which order that you put them in, but I've got a point at 0, 1. So over here, I'm going to plot 1, 0. So over here, I'm going to go 1, 0 and plot a point. I have pi over 2, 0. I'm going to flip them. So 0, pi over 2, 0, pi over 2. And then I have over here pi -1. So I'm going to flip it, -1 pi. So I'm going to go -1 up to pi. And when I create my curve is going to look like that. So like this piece looks almost the same. What flips is kind of this piece goes up here, because this already reflects over the line of y is equal to x. Sort of that piece doesn't really change. I want to again reiterate that anytime you see the word inverse, you need to think inverse. That makes angles. Inverse we use for angles. Okay, again, we use inverse to find angles. Are y'all good with cosine? All right, let's graph tangent. So when we look at tangent, and it's good to have an idea of what tangent looks like. Hopefully y'all did your homework. I know y'all did your homework. So that tangent graph kind of looks like this. If we flipped it on its side, and it would kind of look like that, would the inverse still be a function? Yeah. So do we have to really restrict tangent? Like, we don't really have to restrict it. We have to think about just that parent function, that first curve. And when we think about graphing the parent function of tangent, tangent is a little shorter period because you get 2 cycles in one unit circle, but it runs from -pi over 2 to +pi over 2, where when you see those are your asymptotes. And your graph goes through the origin and looks like that. So nod your head if you remember graphing tangent. That was our first day back from break. So I mean, that is our parent function. We don't have to restrict it. If we flip it on its side, it would look like this. We would still have an inverse. So if we think about that in the unit circle, we're running from -pi over 2 to +pi over 2. Tangent and sine both use the side. of the circle. So we're not really restricting the domain. We're just using the very first cycle of tangent that runs from negative pi over 2 to pi over 2. So we'll use the side again. We've got one negative and one positive quadrant. And so when we look at our domain and our range, the domain goes from negative pi over 2 to pi over 2, but do you ever touch the asymptotes? No. So we've got negative pi over 2 to pi over 2, but we would use parentheses because we don't ever touch. You only use brackets if your graph actually lives there. And then what about our range? How far up and how far down do we go? All real numbers, so we will have that. So when I come over here and I graph my inverse, these just switch places. So my domain will be all real numbers and my range will be from negative pi over 2 to pi over 2. And I'm going to start getting the sketch of my inverse. I'm still going to have an x and a y. And now the only thing that I'm going to label is negative pi over 2 to pi over 2, but it has to be along the y-axis. So that's where my asymptotes will go. And then again, if I'm going to reflect over the line y is equal to x, right now it goes from the origin and it curves up. So now I'm going to kind of go from the origin and curve up this way so that it would be reflecting over the line y is equal to x. And then I kind of curve down like that. What do we use inverse for? Angles. And again, the output when you're doing inverse is to find angles. So the more times we write this, the more that we'll have it in our brains and we'll connect those two things. Inverse finds angles when you're talking about trig functions. We use inverse to find angles. Inverse finds angles. So when we did trig functions before, if I just say cosine of pi over 2, that's going to find you trig ratios. And that's what the coordinates are around the unit circle. Those are trig ratios. Now we're going backwards. If I give you the ratio, you tell me the angle. So we're just working backwards. Anybody still copying this? We good? All right. So for the stuff that we're doing today, and I feel like that the first 6 problems on your assignment are just doing that, sketching the graphs. We just did it together. Those should be really easy for you to do because I just did all of them with you. So you just have to get practice writing those down. That's the first 6 problems of the assignment. And then from there, on to the back, you should be able to evaluate these things not using a calculator. Like you should be able to do inverse trig, no calculator. You will not have a calculator on the exam. So we have to know how to do this. And it's all based off of our unit circle for the most part. So again, you need to have that unit circle handy. So we're going to go through and we're going to do questions 1, 2, 3 together. And I'm going to have you do these on your own. It looks like that I gave myself a note that I want to change that to negative pi over 3. No big deal. I can do that. Okay, for this one, the inverse sign of negative pi over negative square root 2 over 2. Why was I saying pi? So I know that that's going to be restricted. So if I have my sign, Sine goes with the side of the circle. I'm restricting to the side of the circle. So I have to look on the side of the circle, and sine is going to be negative when I look at when sine goes with y. So it's not when I go up, it's when I go down. So I'm going to have to go look in the bottom piece of my circle. It's going to be over here. Where do I find negative square root 2 over 2 as one of my coordinates? What? 7 pi over 4. When UT assesses you, let me just see if I can tell from these answers. Okay, when UT assesses you, they're probably going to assess you with multiple choice answers. So if you have multiple choice answers, it went down how much? Like 7 pi over 4. Do you recognize that that's also the same thing as negative pi over 4? It went down 45 degrees, right? That's probably the answer that you're going to see when you have a multiple choice test for UT, because it has to be an angle between negative pi over 2 and positive pi over 2, and 7 pi over 4 isn't it. So I would have to change that to negative pi over 4. So 7 pi over 4, if I look at it on the unit circle, that's going around, and you go all the way around until you land here, right? So if you wanted to also just look at, because we're doing negative from negative pi over 2 to positive pi over 2, that a coterminal angle for 7 pi over 4, it's only 45 degrees from the x-axis. So we could say that that's negative pi over 4.
Oh, okay.
So these are the same thing, but if I'm restricting the domain between negative pi over 2 to positive pi over 2, I have to find an angle that's between there. Bless you. Next problem. If I'm talking about cosine and inverse cosine, my answer should be an angle. I restrict cosine. Cosine goes with cap. So I'm looking at the top of my circle, and there I have one positive and one negative quadrant. This one is negative, so I have to look in the negative quadrant. And I'm not being approximate when I like sketch this angle out. I'm just showing you which quadrant it's in. In the second quadrant, where do you find cosine? So cosine goes with x. Where's the first value in one of your coordinates? Negative square root 3 over 2. 5 pi over 6. Is 5 pi over 6 a value between 0 and pi? Yes. So we don't have to do anything with it. That is our answer. For tangent, I have inverse tangent. Inverse means I'm looking for an angle. When I have tangent or I have sine, I'm looking on the side of the circle. So again, it has to be an angle between negative pi over 2 and positive pi over 2. So if I'm looking for a positive tangent value, so square root 3 over 3 is positive tangent, I have to be looking in the first quadrant. So when I'm looking at tangent, tangent is the same thing as y over x. So you can look at the second value over the first value to figure out where would sine be. Square root 3 over 3. But you have to do a little bit of thinking. This one is actually going to be where you find the values. Every one is over 2. You're going to have to look for that coordinate, because when you have 1 over the square root 3, we rationalize it to get the square root 3 over 3. So where do you find this coordinate? Whoop, pi over 6. Good job. each one of our answers is an angle. Inverse finds angles. I'm going to give you a few minutes. I want you to answer 2, 4, and 6. So I'll give you a few minutes. Answer 2, 4, and 6. Remember that I made a correction that right here, let's change that to a negative. Yep. All right. For the first one, inverse sine of 1/2. What did y'all find? Pi over 6. You had to look on the side of the circle, and it was positive, so you had to look in the first quadrant. When is cosine equal to 0? At what angle? Pi over 2, you go straight up. You're not moving left or right. You're going straight up. So pi over 2. And for this one, when is tangent going to be negative? So you're going to have to look down here. When is tangent going to be square root 3? So the coordinate you would be looking for that one, you'd have the square root 3 and 1 right here. They both have a denominator of 2, so those would cancel. So you're looking, oh, be negative. Where would we have the negative square root 3 over negative 1? Both negative. I did that wrong. I was thinking that through my head and that didn't make sense. It's only this coordinate or this part of the coordinate that's negative. Both negative is in the third quadrant, and we don't have any that are restricted to there. So sorry, my bad. So yes, what did y'all say? 5 pi over 3, but it is restricted. And guess what? Y'all don't have to think that hard. It's going to be the same as the first quadrant angle, but negative. So like here, when we had to change it, it's just going to be pi over 4, but it was negative. Here, it's just going to be pi over 3, but it's going to be negative. So are we good with these? Yeah. Okay. We need more practice, but we're going to be good. Remember that we use inverse to find angles. That's what's really important. We use inverse to find angles. Moving on. Let me move this down just a little bit. All right, so I'm scooting it over just to make sure that I don't block anything. This was a typo. Y'all's is due on the 28th, so I think that it printed like that. So y'all's stuff is due on the 28th. In your exploration packet, I don't think it's page 94. It was last year, but I don't think it's page 94, but it's the next page where it talks about inverse functions. You can make a note in there that you have supplemental notes for that. So I don't think it's 94, but it is in your exploration packet that I kind of pulled all this stuff. The first question, don't overthink these. What happens if you multiply and then you divide by the same number? It's going to cancel out. So if you have sine and then inverse sine, and that's both of sine, they're going to cancel each other out. So we don't have to think that hard. It's going to cancel. So what I end up getting, so as long as the functions are the same, then I end up with just pi over 3. Here, if the function is the same, so it's like multiply by 2 and divide by 2, as long as the value is the same, they undo each other. So for the next one, again, it's cosine and cosine, cosine and inverse. Something in its inverse will cancel out. So I'm left with what? Pi over 4. The next one, there's a typo. I wrote it wrong. It doesn't even make sense the way I wrote it. So you have to fix it. The way that this was written, inverse was on the outside, so we should have an angle as our answer, and that's not the way it's going to actually work. So here, I have sine and I have inverse tangent. Do these cancel each other out? No, it's like multiply by 4, divide by 7. Those don't cancel out. It has to be the exact same trig function. And if it is, those cancel out. Easy peasy. We're done with those problems. But these also, is this like anything off your unit circle? Those aren't values on the unit circle. So these we have to solve a little different. For these, we're going to build a triangle. So I'm going to build a triangle, and don't stress out. When I build a triangle, I'm going to build it in the first quadrant. I'm going to put my angle right here. And I'm going to label it with what I know. I know that tangent is y over x. So tangent is y over x. So my y part is going to be 3. And my x part is going to be 4. I could use Pythagorean theorem to find the missing side, or I could remember that that's a really common Pythagorean triple. What's my missing side going to be? 5. Now, based on my triangle, could you tell me what the sine of this triangle is? Using SOHCAHTOA, SOHCAHTOA tells me so opposite over hypotenuse. So I've got my opposite and my hypotenuse. So for sine for this triangle that I just drew, what's my ratio going to be for sine? 3 over 5. So when you see these problems, the functions are not the same, it doesn't cancel, and you get numbers that you don't see on the unit circle, then it should be a good indication you're probably going to draw a triangle. The next one, we're going to do the same thing. We're going to draw a triangle. X over 7 is not values on the unit circle. These are not the same trig functions. I can't just cancel them out. Also make the correction because it's written incorrectly. So I'm going to make a triangle again. I'm going to put my theta, and I know that cosine for SOHCAHTOA is adjacent over hypotenuse. So I know that if I label it with what I have X, and then I have 7. No, that's not adjacent. Why did I put it there? That would be opposite. X and then 7. I know that I don't have a value for X, but we can still go through the motions to find this value over here because we need it. Tangent, if I think about tangent, it is opposite over adjacent, or the Y over the X. I don't have the Y value, so I can't tell you what that is, but I could use Pythagorean theorem even with an X. I can have X's in my answer. That's okay. So to find that missing value, I would have the square root of, and it's going to be the hypotenuse squared minus the side length squared. So I have 7 squared minus X squared, which is the same thing as the square root of 49 minus X squared. No, you cannot simplify that. It is the way it is. Don't try. You can't. What would the square root of 49 be? 7. What would the square root of X squared be? X. You could simplify them if they were by themselves, but because they are together and you are subtracting them, you cannot simplify it. So don't force it. It has to stay. Okay, from here. Now, do I know my opposite and I know my adjacent? Yes. Is it going to make an ugly answer? Yes, but that's okay. We're big kids. We can do smart things. So my answer is going to be my opposite, which is 49 minus X squared, all divided by X. Can this simplify? Can this simplify? No, it cannot simplify because I can't break anything out of the square root. So I know that you guys want to simplify it and you want to make it look better and you want to cancel out some X's and you want to do some stuff, but you can't. So it is an ugly answer, and that is okay. It is what it is. You box it and you move on with life. Yes, it also means you don't have to do more math. So like sometimes just don't force it. It's okay. That's as far as we can go. At this point, I want you to make sure that you make a note in your packet so that when you're doing the exploration exam, you have something to refer back to. Oh yeah, we did do notes on inverse functions, so that you know where to find them. And you have your assignment. So your assignment is a couple pages long because the answers are in there. The answers are in the end. So use your answers. You're going to do the odds with questions. Like the last couple questions are kind of challenge problems. Like I don't want anybody like stressing out and getting an ulcer because of those. Like you need to be able to do the first set probably up until probably through question like 29-ish. Like you need to have those down. So we're done for today. Make good use of your time. We still have quite a bit of time, so go be productive.